So today we're going to try another supervised learning method. We're going to try naive Bayes model. So supervised learning. So before we proceed, supervised learning it's where algorithms are actually trained using the labeled dataset to make prediction or classify data. So we have our detailed part one regarding our labeled data sets as well, so you can watch the part one for that one. And let's proceed to the using the naive Bayes model. So naive Bayes model, which is high bias low variance classifier, and it can build a good model even with small data sets. So it is simply simple to use and computationally inexpensive, which is typically use case involved in text categorization like the spam detection, sentiment analysis, and recommender systems. So let's proceed. We're going to type in the operators naive Bayes. Going to use this one and then connect the split data here. Again, we can put in like 0 0.8, 0.2 here, or usually I just put in 0.3 here. 70% is going to our model, and 20%, 30% will go directly into the perform. Sorry, for the result. It's like our gauge in this case. So let's try the apply model. Let's connect this one here, and then the other 30% here. So it didn't go through the naive Bayes uh, algorithm. And then let's proceed in the performance so we can see what the result is. Performance classification, and then here, that's the naive Bayes algorithm. And then again in here we can do the parameters of our naive Bayes. So basically what we're doing right now is just the default, and let's see if we get a better result compared to the decision tree model. So as you can see, it has a better accuracy percentage compared to the previous supervised learning, which is only 88%. This one is it has accuracy rate of 96.60%. So if we look at the prediction here, it predicted false, which is actually false. It means true false. It's actually false. That's the what it means. Then in here it predicted false, but it's wrong. It is true. So it only made a mistake of 8. And then in here it predicted true, but it's false. So this is the wrong. It made a mistake like 94% of the time. It predicted true 443, which is correct. So it has a better precision percentage. So it predicted like 82.5% of all the data to be true or the high risk individual. And this one it's almost like 100% precision predicting the low risk. So it just means that we got a better data sets in the low risk in order to get the class precision as well, and partnered with a good algorithm, we get better class precision and in totality accuracy as well. So in here the class recall, it just means that it has a better like usage of our data, which actually uses like 96% of our data, and no data was lost in transition and all that one. So it has a better recall. So that's our supervised learning method. So compared to the decision tree, this one naive Bayes has a better accuracy. So again, you need to do some parameter changes and try to get as much accuracy. That's the our goal, to get a better accuracy out of the model. So we need to look into the parameters and try to look at the criterion, what we can adjust, and just try to run again and see if it has a better accuracy. So that's it for the naive base.